Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we embark on a journey to Mercury, the small, iron-hearted world hugging the sun. Often overlooked, yet fascinating in its extremes, Mercury holds profound mysteries we'll gently explore together. So settle into your most comfortable position, close your eyes, and prepare to discover the closest planet to the sun. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. With each breath, you become more relaxed, more ready to explore this small world at the edge of the sun's domain. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, creating a peaceful rhythm. Breathing in slowly, filling your lungs with calm. Hold this peaceful moment. Feel the stress of the day leaving your body with each exhale. With each breath, you release a little more into relaxation, preparing to journey to Mercury. We begin our descent toward Mercury, approaching from the sunward side, where this small world appears as a dark silhouette against the sun's brilliance. Even from approach distance, Mercury's small size is evident. At 4,880 kilometers in diameter, it's barely larger than our moon. Just 38% of Earth's diameter, the smallest planet remaining after Pluto's reclassification. Yet what it lacks in size, it compensates in extremes and mysteries waiting to be revealed. As we close the distance, surface details emerge through our imagined view. Heavily cratered, ancient, preserving impact history from the solar system's violent youth. This is not Earth or Mars, with geologic renewal erasing ancient wounds. This is preservation, a museum of cosmic bombardment spanning 4 billion years. Crater upon crater, each telling a story of collision, of asteroids striking this small world throughout deep time. The surface waits patiently to share its secrets. Mercury orbits at an average distance of 57.9 million kilometers from the Sun. That's at 0.39 astronomical units, less than 40% of Earth's distance. But Mercury's orbit is eccentric, the highest eccentricity of any planet at 0.206. This means the distance varies dramatically, from 46 million kilometers at perihelion to 70 million at aphelion. A 24 million kilometer variation affecting solar heating profoundly. Mercury's orbit is elliptical, constantly changing its relationship with the Sun. Mercury completes one orbit around the Sun in just 87.97 Earth days. The fastest orbital velocity of any planet at 47.87 kilometers per second. Compare that to Earth's 29.78 kilometers per second. Mercury races around the Sun, earning its name after the fleet-footed Roman messenger god. Ancient observers watched it appear and vanish quickly in dawn and dusk skies, darting between Sun and Earth. The swift messenger planet, always in motion. But here's where Mercury becomes truly strange. It rotates on its axis once every 58.646 Earth days. That's exactly 2/3 of its orbital period, locked in what scientists call a 3-to-2 spin-orbit resonance. Caused by tidal locking from the Sun's gravitational influence over billions of years. This creates Mercury's most bizarre feature: one solar day lasting 176 Earth days. Sunrise to sunrise takes 2 Mercury years to complete. Imagine standing on Mercury's surface, watching a sunrise. The Sun would take 88 Earth days slowly crawling across the sky from horizon to horizon. Then another 88 days of darkness until the next sunrise. If you stood in one spot, you'd experience sunset 88 Earth days after sunrise. Then wait another 88 days for dawn to return. 1 Mercurian day equals 2 Mercurian years, a temporal paradox unique in our solar system. Time moves differently on this small world. Mercury has nearly zero axial tilt, just 0.034 degrees. Compare that to Earth's 23.4 degrees. This means no seasons from axial tilt on Mercury. The polar regions never receive direct sunlight. This creates permanently shadowed craters that trap water ice, despite Mercury being closest to the Sun. A paradox we'll explore shortly. Even the planet's orientation holds surprises, defying our expectations. Mercury has been known since ancient times, observed by civilizations for thousands of years. The earliest recorded observations come from Sumerian astronomical texts around 3000 BCE. They referred to Mercury as Udu Idim Gud Ud, meaning jumping planet. They noted its rapid motion through the sky and difficulty observing due to proximity to the Sun. Even 5,000 years ago, humanity recognized Mercury's swift nature. Ancient eyes watched this same world we now approach. Ancient Greeks initially thought Mercury was two different objects. They called it Apollo when visible in the morning sky, and Hermes when visible in the evening. Similar to their early confusion about Venus. Around 500 BCE, the Greek philosopher Heraclitus of Ephesus recognized that morning and evening stars were a single object. He unified the dual observations into understanding Mercury as a planet orbiting closer to the Sun than Earth. Observation and reason gradually revealing truth. In the 1610s, Galileo Galilei observed Mercury with his early telescope. He detected phase changes, similar to moon phases, as Mercury orbits the Sun. These phases provided crucial evidence for the Copernican heliocentric model. The phases are only explainable if Mercury orbits the Sun, not Earth. Galileo's observations helped revolutionize our understanding of the solar system's structure. Each generation adds understanding, building knowledge across centuries. But Mercury remained enigmatic for centuries. Always in the Sun's glare, visible only briefly at dawn or dusk. Carl Sagan once said, "Mercury is elusive, hiding in the Sun's glare." Even through telescopes, it's tantalizingly difficult. Too bright, too small, too close to the Sun. We had to send spacecraft there to truly see it. Ground-based observation could provide orbital mechanics and rotation periods, but detailed understanding required direct exploration. Some mysteries demand closer approach. As we approach closer now, Mercury's defining characteristic becomes evident. This planet is unusually dense. Mean density 5.427 grams per cubic centimeter, second only to Earth's 5.514 among solar system planets. When gravitational compression is removed, calculating uncompressed density, Mercury is actually the densest planet. This indicates an extremely metal-rich composition, dominated by iron. The density tells us Mercury's secret. It's mostly metal inside. Mercury's iron-nickel core comprises approximately 85% of the planet's radius. The core extends 3,600 kilometers in radius out of Mercury's total 2,440 kilometer radius. Compare that to Earth, where the core is only 55% of the radius. Mercury is proportionally the most iron-rich planet in our solar system. Imagine Earth's core expanded to occupy everything except a thin, outermost shell. That's Mercury's interior structure. The core contains about 75% of the planet's entire mass. In absolute terms, the core mass is approximately 3.3 times 10 to the 23rd kilograms. With a thin, rocky mantle, only 400 to 600 kilometers thick above the core. This enormous iron heart defines Mercury's character, its density, its magnetic field. A small world with a disproportionately massive metal center. The iron planet at the sun's edge. Why is Mercury so iron-rich? 3 competing theories attempt to explain this extreme composition. The giant impact hypothesis suggests an early collision with another protoplanet stripped away most of Mercury's silicate mantle, leaving the iron core exposed with only a thin, rocky shell remaining. The solar wind erosion theory proposes intense radiation from the young sun vaporized and stripped lighter elements preferentially. And the compositional gradient theory suggests Mercury formed from iron-rich material in the innermost solar nebula. Truth might involve a combination. The violent early solar system concentrating metals toward the sun. The Italian mathematician Giuseppe Colombo explained Mercury's 3:2 spin-orbit resonance shortly after radar discovered it in 1965. He said, "The resonance is an elegant solution. Gravitational tides from the sun's elliptical distance variation locked Mercury at exact ratio. Not coincidence, but mechanical necessity. 3 rotations per 2 orbits minimizes energy state." The Bepi-Colombo mission, arriving in December 2025, is named in his honor. Elegant physics governing Mercury's strange rotation. In March 1974, NASA's Mariner 10 spacecraft conducted its first flyby of Mercury. The mission detected something completely unexpected: a magnetic field. Norman Ness, principal investigator for the magnetometer, described the moment of discovery. He said, "Magnetic field signature appeared on telemetry. I thought instrument malfunction. We checked everything. Signal persisted. Finally had to accept. Mercury has a magnetic field." Room went silent. We'd discovered something fundamentally unexpected. That's why you explore. Theory predicted Mercury was too small to maintain a molten core generating a magnetic field. The textbooks were wrong. Bruce Murray, Mariner 10 project scientist and later JPL director, reflected after the first flyby. He said, "We expected moon-like cratering, but magnetic field was complete shock. Textbooks said Mercury was dead, too small for molten core. Wrong. Mercury is alive magnetically, challenging everything we thought we understood about planetary dynamos. A small planet revealing big surprises." Messenger spacecraft orbiting Mercury from 2011 to 2015 confirmed the details of this magnetic field. Mercury possesses a liquid outer core, likely 200 to 300 kilometers thick. Molten iron shell surrounding a solid inner core, generating the magnetic field through dynamo effect. Though the field is weak, only 1.1% of Earth's magnetic field strength. At the equator, field strength measures about 300 nanoteslas, compared to Earth's 31,000. But it's still sufficient to deflect solar wind and create a small magnetosphere. The magnetic axis is offset northward from the planet's center by about 20% of the radius. That's 480 kilometers shifted north. The northern magnetic hemisphere is stronger than the southern. This possibly indicates asymmetric convection in the liquid outer core or partially frozen inner regions. Despite weak field strength, Mercury possesses a bow shock, magnetopause, and magnetotail. The magnetosphere is extremely compressed on the sunward side, only 1.5 Mercury radii, due to intense solar wind pressure. Now let's consider Mercury's temperature extremes, the most variable in the solar system. On the dayside, surface temperatures reach 430 degrees Celsius at the subsolar point during perihelion. That's 800 degrees Fahrenheit, or 700 Kelvin. Hot enough to melt lead, which melts at 327 Celsius. Hot enough to melt zinc at 420, and tin at 232. Mercury's dayside surface is inhospitable to any known organic chemistry. Extreme heat where metals run liquid on the ground. But rotation carries the surface into darkness, and temperatures plunge. Nightside temperatures drop to negative 180 degrees Celsius. That's negative 290 Fahrenheit, or 93 Kelvin. Colder than Saturn's moon Enceladus surface, despite Mercury being 40 times closer to the Sun. This demonstrates how lack of atmosphere prevents heat retention. From melting metal to bitter cold, Mercury experiences extremes no other world knows. The total temperature variation of 610 degrees Celsius represents the largest temperature range of any planet or moon in our solar system. Compare that to Earth's approximately 140-degree range from coldest Antarctica to hottest Death Valley. Mercury's range is more than 4 times greater. Why such extremes? Mercury has no atmosphere to retain and distribute heat. Earth's atmosphere moderates temperature. Tropical heat spreads toward poles. Night stays warm from retained daytime heating. Mercury has no such buffer, just naked rock facing space. Mercury's atmosphere is technically an exosphere, so thin that atoms rarely collide with each other before escaping. Surface pressure measures approximately 10 to the negative 15 bar. Compare that to Earth's 1 bar of pressure. Mercury's atmospheric pressure is a quadrillionth of Earth's. The total atmospheric mass is less than 1,000 kilograms. Dayside heat radiates to space almost instantly after sunset. Temperatures drop hundreds of degrees within hours. No blanket of air to hold warmth, just vacuum and cold. Just 1 meter below the surface, temperature remains relatively constant, around negative 93 degrees Celsius. The subsurface is insulated from extreme surface variations. But the surface itself experiences the most variable thermal environment in the solar system. Extremes coexisting, furnace heat transitioning to deep freeze with Mercury's slow rotation. 176 Earth days from sunrise to sunrise, experiencing both extremes in that long day-night cycle. Temperature as a function of time and rotation, physics playing out across this small, cratered world. The exosphere, though tenuous, is real and measurable. It contains sodium, potassium, calcium, magnesium, hydrogen, helium, and oxygen. Sodium and potassium produce a faint yellowish glow, visible from Earth using specialized telescopes. These atoms come from 3 sources: solar wind sputtering, charged particles knocking atoms off the surface, photon-stimulated desorption, solar ultraviolet photons releasing adsorbed surface atoms, and micrometeorite impacts, vaporizing surface material during high-velocity collisions. The exosphere is extremely dynamic. Atoms constantly escape. Thermal velocities exceed escape velocity of 4.25 kilometers per second for light atoms. The entire exosphere could escape in days without continuous replenishment. A sodium atom spends an average of 2 hours in the exosphere before escaping or impacting the surface. A temporary cloud of particles, constantly renewed, surrounding this airless world. Tenuous but persistent, a ghost of an atmosphere. Now we settle into orbit alongside Messenger, metaphorically. The spacecraft crashed in 2015 to observe Mercury's surface. Let the complexity become clarity as we explore what spacecraft revealed. No need to rush. Mercury has waited billions of years. It can wait while we learn. Rest in the knowledge as it unfolds gently. Here is Mercury's stunning discovery. Water ice exists on this planet. The planet closest to the Sun, with 430-degree dayside temperatures, harbors 100 billion to 1 trillion metric tons of water ice. Preserved in permanently shadowed polar craters. How is this possible? Mercury's near-zero axial tilt, just 0.034 degrees, means polar craters with sufficiently high rims never receive sunlight on their floors. These permanently shadowed regions maintain temperatures below -170 degrees Celsius. Cold enough to preserve water ice for billions of years, despite proximity to the Sun. Earth-based radar detected bright deposits in 1991. Messenger confirmed in 2012. Neutron spectrometer detected hydrogen signature. Laser altimeter verified deposits in permanent shadow. Nancy Chabot, Messenger scientist, said decades of controversy resolved. Ice on planet closest to Sun. Paradox resolved, but wonder remains. Comets and asteroids delivered water over billions of years. Impactors releasing vapor that migrated to cold polar traps and froze permanently. Some ice is covered by 10 to 30 centimeters thick, dark, organic-rich layer. Complex organic compounds preserving cometary material or resulting from solar radiation processing. Andy Rivkin, Messenger participating scientist, said, "Closest planet to Sun is archive of comets from distant regions." Ironic and beautiful. Ice deposits range from 1 to 10 meters thick, covering areas up to 3,400 square kilometers. Some craters show pure bright ice. Others show ice covered by dark organic material, protecting ice from sublimation. The delivery mechanism is the same process occurring on the Moon and other airless bodies. Volatile-rich impactors over time, water finding refuge in eternal cold. Caloris Basin dominates one hemisphere of Mercury, an enormous impact structure 1,550 kilometers in diameter. That's 40% of Mercury's radius. Formed approximately 3.8 to 3.9 billion years ago, when an asteroid over 100 kilometers diameter struck. One of the largest impact basins in the solar system. The energy was so enormous, it created weird terrain on the opposite side of the planet. This chaotic landscape directly opposite Caloris, where seismic waves from the impact converged, focusing energy and disrupting the pre-existing surface into jumbled hills and valleys. The antipodal effect of a massive impact. Mercury preserving evidence of violence from billions of years ago. Lobate scarps crisscross Mercury's surface. Compression cliffs up to 3 kilometers high and hundreds of kilometers long. Formed as the planet's interior cooled and contracted. The entire planet shrank approximately 7 kilometers in radius over the past 4 billion years. 14 kilometers in diameter. Global contraction creating wrinkle features visible across the surface. Surface hollows are bright, irregular depressions unique to Mercury. Discovered by Messenger, these hollows appear fresh and may still be forming today. David Blewett, imaging team member, described them. Fresh appearance, often within craters, some appearing to expand. We called them hollows. They might be actively forming today through sublimation of volatile-bearing minerals under extreme conditions. Even this ancient world shows ongoing activity in unexpected ways. Volcanic plains cover approximately 27% of the surface, formed by ancient lava flows similar to lunar maria. Most concentrated around Caloris Basin, indicating volcanic activity was significant in Mercury's first billion years, but ceased billions of years ago. The surface is dominated by low iron, high magnesium silicates with relatively high sulfur content. Mariner 10, 1974 to 75, revealed first details. 3 flybys, 45% surface mapping, magnetic field discovery. Lawrence Soderblom, imaging team member, said every image revealed 4 billion years of history. We were first humans to see this world up close. That privilege never grows old. Even now, 50 years later, I remember every image arriving. Messenger completed understanding. Launched August 3rd, 2004. Entered Mercury orbit March 18th, 2011. Sean Solomon, principal investigator throughout the mission, reflected, "Mercury orbit is brutally difficult. Intense heat, radiation, gravitational complexity. Spacecraft spent 7 years conducting 6 planetary flybys just to lose enough energy to enter orbit. Patience required, but reward was complete understanding of Mercury. We finally saw the whole planet." Messenger operated for 4 years, over 10,000 orbits, 270,000 images. Comprehensive mapping, spectroscopy, magnetometry. Ralph McNutt, project scientist, reflected on mission end in April 2015. After comprehensive map, propellant exhausted. We aimed for graceful end, crashing into surface, creating crater future explorers might visit someday. Messenger taught us Mercury thoroughly. Bepi Colombo continues the story. Joint ESA and JAXA mission launched October 20th, 2018. Consists of 2 orbiters, ESA Mercury Planetary Orbiter and JAXA Mercury Magnetospheric Orbiter. Arriving in December 2025, will provide stereo imaging, complete mapping, study magnetic field dynamics. Exploration is a relay race, not a sprint. As our imagined presence settles into Mercury's long night, we contemplate this small world of extremes. Smallest planet, closest to Sun, most iron-rich, largest temperature range, permanent ice in permanent shadow, magnetic field from small molten core, surface preserving 4 billion years of history. Mercury is underappreciated. When people list planets, Mercury often forgotten, overshadowed by Mars's exploration, Jupiter's grandeur, Saturn's rings. Yet Mercury holds profound lessons about planetary formation, extreme environments, long-term preservation, unexpected complexity. Your breath. 4 seconds inhale, 4 seconds exhale. Mercury's rotation, 59 Earth days per spin. Your lifetime, decades. Mercury's age, 4.5 billion years. Surface preserving early history, other planets erased through geological activity. Time on different scales. For billions of years, Mercury has orbited, closest sentinel to the Sun, first planet, innermost world. Surface unchanged for billions of years, except by occasional impacts. Ice preserved in polar shadows for hundreds of millions of years, potentially billions. Ancient observers watched Mercury appear and vanish in dawn and dusk skies. Messenger god darting between Sun and Earth. Modern spacecraft revealed true nature. Not messenger, but archive. Preservation. Extremes coexisting. Ice and heat together. Ancient surface and active hollows. Tiny size and powerful magnetic field. Paradoxes living peacefully. Mercury is tiny, smaller than two moons, Ganymede and Titan. Yet complexity doesn't require size. Even smallest worlds hold mysteries, requiring spacecraft missions, decades of observation, patient analysis to understand. Settling deeper into imagined Mercurian night. Long, peaceful, slow. The sun will rise eventually, 88 Earth days from now, crawling across sky in 176-day solar day. But now, darkness. Cold, -180 degrees Celsius. Silence of airless world. Craters preserving impact scars from solar systems formation. Deep time made visible. Lawrence Soderblom said every image revealed 4 billion years of history. That privilege never grows old. Tonight, we share that privilege. Understanding Mercury more completely. Appreciating this overlooked world, finding rest in its long night. Mercury keeps watch, closest to Sun. First planet, iron-hearted world. At inner edge of Sun's domain. Small but significant. Extreme but enduring, overlooked but fascinating. Ancient vigil continuing. Peaceful orbit. The smallest planet holds vast complexity. Ancient surface preserves deep history. Ice persists in permanent shadow on hottest planet. Paradoxes coexist peacefully. For now, rest in Mercury night. Darkness lasts 88 Earth days. Time enough to understand. Time enough to rest. cratered surface below, stars above, ancient world keeping watch, peaceful stillness. Mercury orbiting closest to Sun, preserving history, silent vigil. Iron core deep within, magnetic field surrounding, ice in shadows, extremes coexisting. Temperature swings cease to matter. Just peaceful observation. Understanding without urgency. Learning through stillness. Mercury continues, ancient orbit, billions of years, timeless motion. Small world, great wonder, overlooked no more. Tonight we understand, tomorrow more to learn. For now, peaceful rest in Mercury's long night. Darkness and cold, safety and stillness. Ice preserved in shadow, volcanic plains ancient, magnetic field weak but present, life in the details. Mercury's day, 176 Earth days. Your breath, seconds. Different timescales, same universe. Floating in understanding. No rush to learn more. Mercury waits patiently, as it always has. Closest planet keeping watch. First sentinel. Iron heart beating slowly. Molten core turning. Bepi Colombo arriving soon. More discoveries ahead. But tonight, rest in what we know. Ancient surface sleeping. You sleeping too. Sharing Mercury's stillness. Peaceful night. Craters preserving time. Ice preserving water. You preserving calm. Rest deepening. Mercury orbit continuing. Your breath continuing. Both rhythms natural. Both peaceful. Darkness surrounds Mercury. Darkness surrounds you. Safe, peaceful darkness. Sleep arriving. No more facts needed, just presence, just rest, just Mercury's long night. Small world, big sleep, peaceful rest, ancient vigil. Mercury watches. You rest. Perfect balance. Perfect peace. Iron core, ancient craters, polar ice, eternal stillness. Closest to sun, farthest into sleep. Mercury, night. Your night. Rest now. Complete peace. Mercury stillness. Deep sleep. peaceful, resting, sleeping. Mercury, night, peace, rest. Sleep now. Mercury watches, silent sentinel. closest to sun, now in darkness. Iron heart beating, slow and steady. Your heart slowing, matching Mercury. Tonight, only rest, only sleep. $4 billion years. Mercury endured. Tonight, you rest. Exosphere whispering. Peace, rest,